test. Okay, can everyone hear me? Okay, hello Melvin, Joan, Ng Wei Ching, Delvin, Jonathan. Okay, so here I am testing out some stuff. Okay. Right. Hello to Yunqi. Beat Touch. Patsy, GM. Nice music. Yeah, okay. Yeah, thank you. Where you get the music from? Music is from a particular game that has been very popular these few days. Okay, so anyway, so now that we've got the vibe going, right, let's start. If you haven't already, you can download the notes here at mathsheuristics.com/blog. So it's a nice song to vibe to, I would say. Okay, can this be recorded? Yes. So today I'll be covering on the SA2 Heuristics revision lesson 5 of 10, which will be on area and parameter. Okay, difficult to remember, Patsy or Bella. Okay, so anyway, let's start. So let me introduce you about Maths Heuristics first. We are a company established way back in 2008, and this is my boss, but this was his image in the past. Okay, so that was way back in 2011 that the Business Times interviewed him on cracking the code to PSLE mathematics. So I don't think I can publish the article here in its entirety due to copyright issues, but if you want, you can search it up. Okay, it's also available on our website. Then second of all, this was what he said way back in 2011, and true enough, many people are using heuristics these days. One way or another, they are all using it. What is the website again to download the notes? mathsheuristics.com/blog. Okay, so later I'll blast the music during the post, so you all can hear more about it. So the main ideas here is that the main ideas we will be discussing comes from the Mastering Heuristics series that my boss has written on spatial visualization. So to find out more about those, you can click here. Okay, let me just click the let me just blast the link first. Okay, and pin it. Alright, so if you like what you see so far, do like and share so that more people can benefit from this. So it's been a bit crazy for on my side. Hello to Diana. Okay, so I haven't been sending out invites for this, but you all know where to find it, so I'm just doing it for regulars mainly now. Okay, so let's dive straight into spatial visualization. Right, now let's look at guided example 1. The figure is made up of a rectangle and two equilateral triangles. So the area of rectangles DEFG is 105 cm squared, and its perimeter is 44 cm. No, it wasn't you, baby. I had to mute it for a while. Okay, so once you got this ready, how can we find the perimeter of the figure? Now let's look at this figure in its entirety. And let's admire it. We know that this is made up of two equilateral triangles. So we know that these lengths of the equilateral triangles are all the same. Correct? Then you see that you only know the area of the you only know the perimeter of the rectangle and its area. You are not given the lengths and breadths, how they are related. You're not given information on how the length and breadth of the rectangle are related. So over here, let me just give you a quick poll first. Then I'll blast the song again. Okay, so let's look at the poll now. Okay, there is not enough information to find out the length and breadth of rectangle GDEF, and hence this question is unsolvable. True or false? This Okay, so anyway, I'll pause the poll now. Some of you say that the answer is true, when in fact the answer is categorically false. There is enough information to find this out. Okay, so anyway, I'll close the results now. So most of you got it correct. The answer is false. There is enough info to find out the parameter of this figure. So let's look at how we can do it. There's this, you have this long lost friend called guess and check or trial and error. Okay, maybe let me type this out. What game music is that? Okay, I better not tell you all about it first. Okay, so anyway, how can this be done? We want to do this by saying that there is a certain breadth and there is a certain length here. Correct? But we do not know exactly what they are. So what we want to do, okay, maybe the question was set way back in 2006 and they didn't specify one parameter, that the lengths when measured in centimeters are whole numbers. Can it be assumed? No. So here the length and breadth itself, because the parameter of the rectangle, right, is 44. If we divide this by 2, we will obtain the length and the breadth combined. This is the length and the breadth combined. Now after we've done this, we know that the area of the rectangle is 105 cm squared. So what we can do is to say that is to check all the combinations of length times breadth to give you the area. Okay, why are that? Okay. Okay, so for the length itself, the smallest possible length would be, the largest possible length has to be 21. Now it cannot be 22 because if it was 22, right, your breadth is going to be 0. And in that case, you would end up with 0 here, which means that you have a straight line. You should not consider this. Okay, as a good practice, don't consider this. So what you want to do instead is, because your length is strictly longer than the breadth for a rectangle, for this particular rectangle at least, because some of you will argue that a square is also a rectangle, okay? Means you've been listening. So we want to try out all the combinations first. This is 21. This is going to be 40. And why do we do this? The reason is because you want to check out the combinations such that your length and breadth add up to 22. Okay? How about factors? That also works. That also works. So let me just go through this way of doing first. The other one is 19 times 3 to give you 57. This doesn't work. That's something I'm about to go through also. Then you want to try out 18 times 4 to give you 72. Yeah, this doesn't work either. 17 times 5 to give you a 5. Doesn't work either. What's wrong with this calculator? And 16 times 6 to give you 96. Doesn't work either. Then 15 times 7 to give you 105. Then you know that this area, this combination works. Okay, the other alternative is to use systematic listing of factor pairs. Right? Which is like, for you want to find out what makes up 105. Okay, what can make up 105? 1 times 105 gives you 105. Then you want to slowly, systematically increase the length, increase the left hand side. Then you have 3 times, and see which is divisible. 105 divided by 3 will give you 25. That will give you 105. 5, okay, 105 is divisible by 5. You ignore those that are not divisible. Okay? But if you do it this way, it's a bit more troublesome. Because you see, you have to do 7 times 15 already. 105 cannot divide by 9, cannot divide by 11, cannot divide by 13. Then it goes back to 15 again. Because if you do it this way, you have to check the parameter will be 105 plus 1 plus 105 plus 1. So the parameter is not going to work out. Parameter will be 105, 212, but you get the idea. This one will be 3 plus 35 plus 3 plus 35, 76. Okay? So this doesn't work out. This doesn't work out either, because 5 plus 21 plus 5 plus 21 gives you 52. And the last one will give you 44. Or you can also just check length times breadth. Today, why are you not using dark mode? I got complaints about the brightness issue. People cannot see properly. Yeah, so this is correct lah. I mean, wait, hang on. This is correct. Why I go and put cross? Okay. So so you all get the idea. The main thing you want to deduce is that the breadth is 7 cm long and the length is 15 cm long. That's what you're trying to deduce over here. Okay, so we've cleared the first part of the question. What do we do next then? Yeah, gestural I saw wrongly. I was like, okay, what's the parameter of the figure? So based on this, we do not know these individual lengths. So what can we do from here? Hey, y'all like it when I fumble, very funny. Okay, but okay, so since you cannot find the individual length, because there's really not enough info for you to find out what is this and what is this individually, what we can do instead is to say that both of these will add up to 15. And once you've got that, we can say now that this length and this length adds up to 15 cm. Okay, then this length, okay, this length and this length adds up to 15 cm. And of course, our breadth over here is 7 cm. Now, once we've got all this ready, the answer then would just be, okay, we just need to add up everything together. 15 cm plus 15 cm. Okay, maybe don't even write the units here. So that will give you 59. Then the answer here, the parameter of the figure, is going to be 59 cm. Okay, so most of you got it. Yeah, I'm not too sure what's wrong with Adobe Acrobat these days. Okay, Keshav, Melvin, Yunqi, Samuel, no. Ng Wei Ching, Melvin, you all got it. Victor got it. Okay, got easier way. Not exactly. It's either the two main ways of getting your length and breadth are these two ways. At least these are the more common ones. Okay, maybe there exists some other method that I'm not aware of. Hey, why okay, so got it, Okay, Jamie, Ashlyn. Xiao Wei, okay. Parameter of the rectangle plus 22. Okay, so anyway, yeah, it's to show you that this type of question can exist. Okay, so number 2, the figure is formed by 3 squares. If you've attempted it just now, if you've downloaded the notes and attempted it before this session, you will encounter the same problem. So here I will give you, where is it? Okay, so I'll give you another poll. Figure is formed by 3 squares. The side of each square is a whole number. If the total area of the figure is 142 cm squared, what is the parameter of the figure? So over here, Gather example 2's poll says that there is not enough information to determine the lengths of the squares, and hence this question is unsolvable. Okay, Delvin, don't fool around this. Yeah, no, I won't talk about this where this music is from for the time being. Okay, maybe after your PSLE or something, but not now. Okay, y'all catch my pattern already, If it's unsolvable, then why is it a question? Yeah, good point, Maggie. Good point. The poll should be inside the inside your phone, or if you're viewing the desktop, it should appear at the side panel. Is this from some old time show in the disco time? No, it's not. Okay, so okay, pause poll first. So yep, it's false, right? It is definitely false. Okay, because this question is solvable, it's just that you're not too familiar with what tools should be used for this. Because this question, you seldom see it in various groups these days. It still exists though, so that's the point I want to make. But anyway, let me just go through this idea with you first. You have got 3 squares here. The side of each square is a whole number. Now when you see something like this, be prepared to list a lot. You all can try to keep on guessing. If you don't know the name of this, right, it's better that you don't know. Be prepared to list a lot. So if the total area of the figure is 142 cm squared, what is the parameter? Now what do I mean by be prepared to list a lot? You don't have enough information, so you need to use either listing or guess and check or supposition. Okay, so to deal with this, right, you want to list out the length and the area of the squares. Now because the lengths are given in whole numbers, okay, because the length of each square is given in the length of the squares are given in whole numbers, there's only so many you can list out. So what you want to do is, if this square's length is 1 cm, then the area will be 1 times 1 to give you 1. If the length of the square is 2, the area of the square will be 2 times 2 to give you 4. So these are your square numbers. You have to get really good at least the first 10. Memorize at least the first 10, okay, because it will help you with certain pattern recognitions. Those students on Teach Art, how do you all enjoy last week's lesson on square number patterns? You all love it, right? But more importantly, you all love the additional 6 questions you all got. Giving you all your money's worth. Okay, so now you get 1, 2, 1, 12. 12 times 12 will give you 144. Now the question next is that, when do you stop listing? Okay, Nicole, what is length times length? Length times length gives you the area of the square. Yeah, it has these 3 figures are all squares. I mean, the 3 of these shapes are all squares, and therefore the area can be found by computing length times length. 很好 right, K 啦。Okay, okay, don't worry, Nicole. So once you got all this, when do you stop listing? Method of exhaustion, yeah. Correct. Javen, yeah, correct. So square numbers here. Stop listing when the area has exceeded 142 cm square. Okay, very good, Lina. You're correct on that. You see, the area here, 1 square alone already exceeds 142 cm squared. So you know that it cannot be the case already. You have to get rid of this. You have to stop somewhere. So now the other piece of info that we know is that the total area of the figure is 142 cm squared. So what we have to do now is to look for a combination of numbers that adds up to 142. Okay, so here there is a lot of trial and error involved. Okay, wait, let me see. There's a lot of trial and error involved. What do y'all think? So I give y'all a discount. One of these numbers is 81. Okay, Jaylin, you got it correct. Okay, the three numbers, if you look carefully, because I'm kind of rushing for time, but if I have more time, I will definitely let you try this out. Now, the trick here is to look at the ones place of the total area. You're looking for three numbers that add up to 142. Correct? So now, you want to look at the ones place. Because you want to find out three numbers that will give you 2 in the ones place. Okay, this will help you narrow down what you need to find. So Joan is also correct. Format. Yeah, so you want to test this out and you will see that 25, 36 and 81 will all add up to 142 cm squared. So over here, this means that the lengths of the squares are 5, 6 and 9. Okay? So when I gave a question to one of my students way back, I think in 2014, I don't know whether he was trying to be funny or what. He asked me which length goes to which square. How would you approach this question using supposition? No, I wouldn't do this using supposition. This is one of the alternative you can use, because sometimes you have to assume worst case scenario, assume maximum number, assume minimum number, that kind of thing. But this one is a very generalized statement. Okay? Kayla, permission for what? What is supposition? It's just that I don't have space to type it out. So over here, you go according to the shape of the square. This is the smallest, so it should have the smallest length. This is the largest square, so it should have the largest length. This is the medium square, so it should have the medium length. Correct? So once you have established this already, the next thing you can do is to find out the parameter of the figure. Let's just save some time because got to clear this in 1 hour. So we can say that this entire edge adds up to 15 cm. Yeah, okay. Time attack is always about speed runs. So these three edges should also add up to 15 cm. Okay? Supposition not for this question, but it's more like, okay, later I address that. Then these three edges should also add up to 14 cm. Correct? So once you got this already, 14 plus 14 plus 15 plus 15 will give you 58. So the answer here would then be 58 cm for the parameter of the figure. Okay, what do I mean by using supposition for? It's when you don't have enough information. You all know the question, what you call? 2018 PSLE question on, I think, 508 chocolate tarts or something. Do you all remember that? That question you also don't really have enough info, but you want to find out the maximum number of boxes required. So you need to maximum or minimum number of boxes required. So to deal with that, you have to assume that you have a lot of everything. So I'm saying this, you use supposition. Using supposition is one of those options to make when you don't have enough info. Okay? Yeah, Sophia, you're correct. Dominic, you're correct. Okay, we're gonna speed run this whole set from here on. Do you know laser beam? No, I don't know. To be honest with you, I don't watch Twitch a lot. In fact, I've kind of stopped playing games ever since the whole circuit breaker thing started. Okay, so you all got it? You all got it? Please spam the like button. Alright, number 3. ABCD is a square of area 104 cm squared. E and F are the midpoints of AD. Okay, AD is here, so E is the midpoint. This one should be CD or DC. Okay, this one should be DC. Please change it. So find the area of the shaded triangle. How do you know the 3 numbers faster? Okay, wait. Wait, please don't do that here. Don't make me do that. Don't make me say brute force in that manner. But anyway, number 3. Let me just give you all the poll first. Okay, there's no right or wrong answer for this poll. I must stress that there's no right or wrong answer for this. Okay, so here's the poll. Here's the music. How should this problem be solved? Let me go and open up the Wi-Fi place first. Open up the door, then the Wi-Fi can come in. So you all see this option? Wait, Hey, you're very bad, you know. Why is the last option there? Why is the last option there? I show you why. You see the number of live viewers now is about 84, right? It's actually meant for those people who will never answer anything. Now currently the live poll I see is 84, 86. But only got 4150, so I made this option for them. It's supposed to be a joke, but it's right now the most selected option. Hey, you're very bad, you know. Okay. Off the music, off the poll already. Okay, wait. Hey, Shirley, don't. Okay, so anyway, there's no right or wrong answer lah. But most of you see, you all would tend to use this option first. You all would try to just find the square root. Because, oh, I learned square root, I must apply it. You know what I'm saying? But here is the trap. If you try to do square root for this, right? You end up with a never-ending series of decimal numbers. We call these irrational numbers, but you'll learn more about that in secondary school. Okay? So try not to use square root when you encounter a problem like this. You want to use the rearrangement of parts. Finding out the fraction, it also works. Finding out the fraction also works. But I don't think everyone can get it. So for those of you who are more visually inclined, this is what you can do. You can cut up this entire square into 4 smaller squares like this. And of course, these lines are perpendicular. So once you have this already, right, you want to move this feather over here. And you want to move this feather over here. So now this portion becomes shaded. This portion becomes shaded. This portion becomes unshaded. This portion becomes unshaded. Okay, then the second thing you can say is that if you are to partition this, this now resembles those paper 1 problems really. Okay, you can now cut all these into identical triangles, and you can say that 3/8 of the figure is shaded. So once you got this already, we can say that the area of the shaded triangle that now has to be 3/8 times 104 cm squared. Okay, all the students of Teach Art, right? You all like the music, You all like the music, tomorrow I blast more. Okay, so the answer here will just be 39 cm squared. What is meant to be a joke, you all take it as the serious answer. Yeah, Shirley, you're correct. Yeah, RNH, I think you found the wrong one at first. This one can square root. Try not to do it by that way. Y'all haven't learned how to deal with irrational numbers yet. Yeah, Wei Ching, you're correct. Connie, no, it's not 42. Pythagoras, try not to dabble with it unless you fully understand what you're doing. 104 divided by 2, no. The fraction of the figure is not that. Rearrange is one of the easier options, I would say. It's something that everyone can understand. Okay? So yeah, we're gonna speed run this guy down. Yeah, everyone got that? If you got it, if you're vibing, please spam the like button. Okay. Waiting for everyone to get on track. Okay, if you don't know what a square root is, it's okay. You'll learn more about it in secondary school. Okay, So, okay, let's go on to number 4. So for number 4, the figure below is not drawn to scale. What fraction of the figure is the total area of the shaded regions A, B, C, D, E, F, G, and H? You want to find out the total area, okay, of A, B, C, D, E, and H. Of course, this question was set way back in 2007. I think the setter's intention is that these lines should all be parallel. Okay, all these lines should be parallel to one another. And of course, this side also. Okay, I'm not gonna put this. Did you put that option? No, I didn't put Pythagoras because it's something that I don't think you all would have. I don't think your teachers would talk about it. at least in school lah. Maybe other tuition centers, yes, but not at least not in school. I don't think you all will go through that. How to find the area of parallelogram? Okay, so to conserve time, I don't think I'll give any post for guided example 4 or guided example 5. But the main idea here is this one will end at 9. I aim to end at 9. 5 questions, 1 hour, I think quite reasonable. So here, you all haven't learned how to find the area of parallelograms yet, so that finding the area through parallelograms is out. So one of the best ways to solve this problem is to rearrange them by sliding. Okay? Slide them into their respective regions. So you see that this vertical height here is 3, this vertical height here is 3. The total height here is 6, so it's going to slide in nicely. And it will fit in here. And F will fit in here nicely. For C and G as well, the total height is 6 cm. There's 3 cm there, 3 cm there. So this will slide in nicely over here. And finally, for A, there's 4 cm, there's 2 cm, there's 6 cm. You can see that this will fit in nicely over here. Correct? Cut into triangle. That will be a bit overkill, I think. So once you have this already up, after you've done all these, you have rearranged them into something like this. Okay? Whereby this whole portion is now going to be shaded. So this is 6. And the total length here, if you add up everything, is going to be 18. Right? So basically, because your length is the same, right? You don't have to bother about the length itself. Because, I mean, if you want to really go into details, here's what's going to happen. You have 6 times 18. The fraction of the figure that is shaded, the shaded area will be 6 times 18 divided by 18 times 18. So when you deal with your fractions, you want to eliminate whatever common factors you have first. So 18 and 18 gets cancelled out straight away. Then you work on 6 and 18. This will give you 1 out of 3. So the fraction of the figure that will be shaded is 1 out of 3. Is the width the same also? Yeah, because if you add up everything here, 4, 3, 6, 3, 2, that will add up to 18 also. Have no fear, Kevin is here. How do you know it fits? Because if all these lines are parallel, then it will fit. Why do you take 6 times 18 divided by 18 out of 18? Because you want to find out the shaded portion out of the total area of the figure. So over here, what some of you will be wondering is why I take 6 times 18. It's to find out the area of the shaded portion. And the other one is to find out the area of the entire figure. But of course, if you can see it, because they share the same length over here, right? This 18 will cancel out each other. Yeah. These 18s will cancel out each other. How many marks would this question be? Probably about 3 to 4 marks. Yeah, this one so smart, yeah. Okay, I would say that my mentor taught me well. Okay. But you can tell two straight away too, right? Huh? Tell about what? What is your favorite fruit? What is your favorite fruit? The one that doesn't eliminate me. Okay, some of you will get it, some of you won't. Okay, so you got it, please spam the like button. Divide by 3 is 6. Huh? Yeah, never mind. The music is so cute. How can anyone hate this? Like really, what is the problem with people hating on cute things? Okay. Yeah, okay, anyway, number 5. So some parts are cut out from a rectangle ABCD resulting in the shaded figure below. If the area of the shaded figure is 110 cm squared, find out the area of ABCD. So now, by now, you already got this idea. The rearrangement of parts. Okay? And if you haven't spotted it yet, today we went through this central idea, rearrangement of parts. The idea here is you want to rearrange the figure in such a way that the formula up to P6 can be used to find out, or rather to solve the problem. Alright? That's the main idea here. Because over here you don't have enough information outright, the first thing we can say is that this guy needs to be moved over here. If you move this over here, that's also fine. There's another slightly different way to solve it, but the main core principle still remains the same. Gwenda, you're very close. So when you move this over here, okay, what's going to happen? This part becomes shaded. Okay, so let me show you my magic. This part now becomes shaded. And this part now becomes unshaded. Oh, magic. Look at that. Okay, so I can do this magic easily on PDF, but on your paper you have to be aware that that portion is gone. Alright? Why everyone say 125? Yeah. Alright, so once we got this already, the next thing, what do you think we can do? Pi, we don't need pi for this. So remember, these were originally quadrants. So when this is a quadrant and this is the radius, you would have a certain unknown length over here. Let's say this is 1 unit, this is 1 unit. Okay, on this side, this will also be 1 unit, and this will also be 1 unit. Sorry, I'm not too sure what happened here. My Adobe is getting a bit flickery these days. Yeah, you want to find out the area of the big rectangle. So now my question is this, what is the value of your 1 unit? Push the 2 lines out. Push the 2 lines out. Okay, so a few ways this can be done from here. Right? You can first, you need to partition this in a way that you can calculate it using your known formula. So if we partition it like this, you have 10 cm for this length, you have 1 unit for this breadth, which means to say what? you are going to have an area of 10 units here. 1 unit is 5 cm, no. Nana, it's not. Okay, Nana, it's not. So the next one is what? The next one is, the next piece of area that you can find is this guy over here. Well, very hard to see. This area over here will have an area of 10 times 5 to give you 50 cm squared. Correct? And finally, over here, on this side, so you can see clearly if this is 5 cm, although the figure is not drawn to scale, but the main idea here is that 1 unit is strictly less than 5 cm. Okay, you have 1 unit here. Okay, you have 1 unit as its breadth, 5 cm as the length of this red triangle. So you have to be able to see that over here this is 5 cm. Then when you multiply it out, you get an area of 5 units for this whole portion. Okay? Emily is not. Shh. Focus on the lesson, please. Yeah, unfortunately I can't mute everyone here. But fortunately on Teach Arc I can. So yeah, this is supposed to be a fun session. Now from here, can you all solve and find out the value of 1 unit first and then find out the area of the shaded figure? So I think there's still a bit of time. So I'll just let you all try first. Try 5 units. Length times breadth. Sharon Pang, the reason is length times breadth, to give you an area of 5 units here. Why is that part 10 units? Because the length here is 10 and the breadth here is 1 unit. Okay. Then for this 50, it's 10 times 5. Your song so loud. Okay. Yeah, okay. Jasriel, you got it? Kishaf, your answer is at the beginning was wrong. Okay? But good attempt. Okay, aim to make one new mistake every day. Like, aim to be exposed to one question that you don't know how to do every day. Because this means that you are constantly growing. So over here, what we can do next is we add up all the units. And the 50, this would mean that the total area is 110. If you don't know how to do this, it's perfectly fine. Okay? So you want to try to break it down in this manner. Partition whatever you can first. Get 60, 1 unit. If you need to draw out your model to solve this, do it. So 1 unit will be 4. Now when 1 unit here is 4, you know that this length here is 4 cm. You know that this length here will be 4 cm. So the area of the whole rectangle ABCD would be 14 cm times 9 cm to give you 126. Correct? The entire length now will be 14 cm. The entire length now will be 9 cm. So final answer will be 126 cm squared. Yeah. It's okay. It's okay to get it wrong. Not too bad. I think today 5 questions, less than 1 hour, less than about 50 minutes. Not too bad. But you all know in Teach Arc it's gonna be a lot more aggressive. Okay, so if you got it, please spam the like button. Yeah, Emily, you're correct. When is this gonna end? Very soon. Yeah, so if you got it, please spam the like button. Remember to like and share. Okay, and if you would like to view more of these, you can find out more from the pinned comment section down below on the spatial visualization books that we have. Okay, written by my boss and my mentor, Mr. Sani Tan. Alright, just play the music until the end. Yeah, I got the whole playlist here. Yeah, whatever you all do, don't go and play a new game right now. It's gonna be very, very dangerous. Hey, welcome Jasriel, welcome Kayla, see you tomorrow. For guided example 2, how to find out the 3 numbers from all numbers. Okay, for Sharon, okay, for Sharon. No, I'm not going to show you the playlist. For this, the main hint is you want to look at the ones place. You know what I'm saying? You look at the ones place and then you check for 3 numbers that can give you a 2, a digit 2 in the ones place. This will help you to eliminate off certain combinations. Okay, see you tomorrow, Delvin. Yeah, wait, let me show us the playlist. No. Okay. So, yep, see you all tomorrow. Good luck for PSLE. Hey, welcome, Connie. Hey, welcome, Diana. Hey, welcome, Ellie. Welcome, Delvin. Welcome, Wei Ching. So sad. Hey, welcome, Emily. Okay, welcome, Bella. I tell you all a little story about me. Okay, what I did was my P6 year, right? Okay, story time with Kevin. My P6 year was 1999. Okay, and in 1999, CS just came out. It was in beta version. Then every day, for some reason, after I try out a few times, my friends keep on asking me to go and play with them. Play until nearly 走火入魔. So you all better not start on any new game right now. I can show you all the music and all that. I can let you all hear the music and all that, but I won't show you the game. Okay? What is CS? Counter-Strike? Alright, see you all tomorrow. It just came out. That time there was like CS Siege, CS Assault, and this one you all probably never heard of. Desert. Yeah, I don't think you all heard of Siege. Yeah, RNH, I'm correct. Yeah, you're correct. Street Fighter. No, I'm never really a Street Fighter kind of person. I only know that when I play Street Fighter, my brother can play for 1 hour using 1 credit because he keeps on winning. But for me, I go there to help people sustain that time at the machine. So yeah, I'm not a Street Fighter kind of guy. Okay? Yeah, whatever you do, don't go and start a new game right now. Very dangerous. You're gambling with your future options. Okay? Bye bye. Okay lah, so if nothing else, I'll see you all soon. Okay, good night. Take care. Stay safe, stay healthy. This is Kevin from Heuristics signing off. Thank you all for having me. See you all next time. Bye bye.